Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about alkene hydrogenation reactions. There are two types of these that are important at this section. There are two types of these that are important at this point in the course, and we'll go through both of those examples. This is a catalytic method for converting an alkene into an alkane. These involve syn additions, which means that we're adding the hydrogens to the same face of the pi bond. We'll talk about that more in the mechanism section. This requires a metallic catalyst. Some examples that work are platinum, palladium, palladium over carbon, and nickel. And then there are two examples, a homogeneous and heterogeneous. This involves the reaction of this cis alkene undergoing a reaction with hydrogen gas and platinum to afford this product only. So this is the only stereoisomer that's formed in this reaction. Now, first things so I want to just explain a few things first. If this reaction is subjected to just hydrogen, that is this alkene plus hydrogen, there will be no reaction. This reaction requires platinum to enable this reaction. And what platinum does is it provides a surface, right, by which we can absorb hydrogens, okay? And then the alkene will attach itself and interact directly with these hydrogens that are here, okay? So the transition state involves the alkene coming and adding from the top of those two hydrogens, so they add at the same time. So this reaction is also concerted and stereospecific. Remember that stereospecific means that the stereochemistry of the reactants control the stereochemistry of the products. And oftentimes we have only one stereoisomer that's formed as a result of this stereospecificity. So in addition to platinum, you'll see other catalysts like nickel and what's written as palladium over carbon. There's also the possibility of a homogeneous catalysis. And homogeneous catalysis is different from heterogeneous catalysis in one major way. Homogeneous catalysis means that the catalyst itself is dissolved in the solution in addition to the substrate. So everything is all dissolved. It is a homogeneous solution. Heterogeneous catalysis is a bit different. There's usually a metal slab or some kind of there's usually something that's insoluble with the reaction mixture. So you can imagine one of these which wouldn't dissolve in the solution itself, making this heterogeneous. An example of a homogeneous catalyst is the Wilkinson catalyst. The Wilkinson catalyst is a rhodium-based catalyst, which is shown here. I'm going to circle it in blue. So this whole catalyst is represented here in this reaction. You can write just the words or you can draw in the structure. Either is generally fine. And you'll add H2, hydrogen, of course, to hydrogenate this alkene. You'll notice that the products are identical, whether you use the metallic-based catalyst, the heterogeneous catalysis, or the homogeneous-based catalysis. It's still a stereoselective, concerted syn addition to the alkene, but just the setup of the reaction is different. Some questions you might want to ask in office hour. 1, why do only some metals work for this reaction for the heterogeneous catalysis? 2, can you just dissolve hydrogen in solvent to make this reaction homogeneous? 3, and are there any alkenes that won't undergo reactions with hydrogen and palladium, platinum, or nickel? So with that, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.